Number 5, lengths of diagonals in meters. 9 most popular flat screen TVs and 9 most popular conventional TVs are shown below. So they give us some data. This is raw data. Represent the information on a back-to-back stem and leaf diagram. Okay, so remember we got to break these down. Now we got to take a look and see what our stems are going to be. Remember the leaves only can be one digit. So if you take a look, we've got 6 and 7s and 8s and 9s and a 10. So let's go start by going 6, 7, 8, 9, and 10. And then we're going both sides, so we'll create 2 lines. And then we got to make sure we're clear about which ones are on which side, so we've got to label it. I'm going to put the flat screens on the right and the conventionals on the left. Doesn't make a difference. And then we're going to start putting our data in there. So for the conventional, keep in mind we're going to go from the middle outward. And so the first piece of data is the lowest number. We have to go in order. Is going to be 0.65, and then 0.67 and 0.69, and then I got 0.71 and 0.74 and 0.75 and 0.77. And then I take a look and I see another 8, so 0.85 and 0.86. And that takes care of conventional. So now I start with the flat screen. The smallest number is 0.76, and then I got 0.85 and 0.89. And then I've got 0.91, 0.92, 0.94, 0.96. And then the 2 larger ones, I've got 10.4 and 10.7, if you will. Not really. And make sure whenever you do a stem leaf diagram, you've got to make a key, especially if it's back-to-back. You got to let people know how to read both sides. So 0.76 for the flat screen and 0.71 for the conventional. I've seen it where they just do the weird side, the left side, but save yourself, I would do both. Anyway, for part 2, find the median and the interquartile range. Well, keep in mind the median is roughly halfway, and we've got raw data here, and it's been ranked. We just made a stem and leaf diagram. So if I take it, it's going to be the 5th piece of data, and I find out that 0.74 is the median. And the interquartile range is going to be Q3 minus Q1. Well, that's the median of the lower quartile and the median of the upper quartile. We subtract them. So in this case, keep in mind, if you find the median of even numbers, in this case it's only 4, well, then it's going to be the average of those two. So Q1 is going to be, if I multiply 4 times 0.5, it's going to be the average of the second and the third piece of data. And so if I do that, I'm going to find the average of 0.67 and 0.69, which is 0.68. Now, Q3, that's the average of the top, or I've got to find the middle 2 for the top 4. Anyway, it's going to be 0.77 and 0.85. The average between those is 0.81. If I subtract 0.81 minus 0.68, I get 0.13, and that's the interquartile range. Now, for number 3, it says find the mean of the flat screens and the standard deviation. And you can use your calculator for this, but really all you got to do is add them up and divide by 9. You don't have to use the rank data. You can pull it right off the original table. And we can find the mean is 0.926666 repeating. And then we can round that to 3 significant figures. Now, for the standard deviation, again, you can probably put this in the calculator. But remember, all we're going to do is add up all the x squares, divide by the number of pieces of data, and subtract the mean squared. And there aren't that many pieces of data here. You probably could do it just as fast by hand as if you put it in the calculator. Anyway, make sure that when you do that, that you use the mean before it's been rounded. And then keep in mind, what we've just found using this formula is the variance, not the standard deviation. We've got to take the square root of it in order to actually get the standard deviation, which will be 0.0882. All right, number 6. In this one, they give us the lengths, or they give us some information. We've got 600 feathers, and we find that 63 are less than 6 centimeters long, and 155 are more than 12 centimeters long. And we're trying to find the mean and standard deviation. Now, the fact that we're looking for 2 things, and they're giving us 2 things, kind of gives me a good idea that maybe we're going to be solving 2 simultaneous equations. So anyway, they didn't hand us a probability, but they did give us an experimental probability. 63 times out of 600, it was less than 6 centimeters. And 155 out of 600, it was more than 12 centimeters. So those are the probabilities that we're going to deal with. So what we're going to do now is basically create two equations. And we're going to take the information they've given us, these two pieces, and we're going to make an equation for each one. And we know we're going to have two variables. We don't know the mean and the standard deviation, but we'll plug in what we can. We have to find a z-score, and we're going to make it equal to another z-score that matches up with the probability. So let's take a look here. If we've got 0.105 and it's less than that, well, that means we've got to be over here on the right-hand side of the mean, and only 10%, 10.5 is going to be below me. All right. So the problem is that's a negative z-score because it's going to be below the mean. I only have positive z-scores on my table, but I can find a symmetrical brother over here. And again, another problem I have is that my z-score table goes to the left. I can do less than that z, but I can't do greater than that. But that's fine, because if I take 1 minus 0.105, I know that I've got 0.895 over here to the left. So I'm going to find that probability and then find the z-score that matches up with it. Keeping in mind, that's the positive z-score. I need to make it negative because the one I really want is its symmetrical brother. So then all I got to do is write an equation out of it and then go to the other one, do the same thing. Again, I'm going to do 12 minus mu over standard deviation, and it's going to equal this, but I need to find the z-score that matches this probability. Now, if it's going to be greater than this, and it's going to be 0.25, now I know I'm above the mean. And so this z-score, now again, my z-score goes to the left, so I just take 1 away, and I find out that I need a probability of 0.741667. And then I go to the table, and I look in the middle, that's where the probabilities are, find the z-score that matches that, and I write my second equation. And see, now all I've got to do is solve them simultaneously. I'm probably going to take one of them and multiply it by -1, and then just stack them up and add them together. So let's see, take this second one, let's see, 6, -6. It'll be giving me -6, and then positive mu, and then positive 1.253. And then all I'm going to do is add straight down. And I'm only going to have my standard deviation now. And so when I divide, I find my standard deviation. And I take that standard deviation and I plug it back into one of the equations, making sure that I don't plug in the rounded one. And then I just solve for mu. And I find out that my mu is going to be 9.95. And that's all there is for that. All right, so part 2, it says we've got 1,000 body feathers of birds, and how much would we expect to find more than one standard deviation from the mean? Now, I know it doesn't seem like they've given us much information here, but if we draw a normal distribution that's standardized, that means the mean is 0, and then we put our standard deviations, and keep in mind, almost all the data is going to be within 3 standard deviations. This is representative of our z-score. These bottom numbers, 1, 2, 3, and -1, -2, -3, well, actually the 1, 2, and 3. These are the z-scores that you find on the table. So if I'm 1 above and 1 below, well, basically what I want is I want the area that's in green here. And keep in mind, when I say area, that's the same thing as the probability. So how can I figure this out? Well, I've got the z-scores, and so I don't have to change anything. It's there. Z-scores are 1 standard deviation, 2 standard deviation, and 3 standard deviation, and all the increments between. This question really is about determining whether you understand that these z-scores are really standard deviations. So anyway, all I've got to do is go to the table and find the z-score 1, and then find the probability of everything to the left of it, which will be represented there, and we're just doing 1.0. So the area to the left is going to be 0.8413. Now keep in mind, that's not the green area, that's everything to the left of 1. But if I take 1 minus that, that's going to give me the green area on the right. Now remember, everything is symmetrical, So if I multiply that by 2, that's going to give me both green areas. And remember, when I say area, that's the same thing as probability in this situation. So if I take this probability and multiply it times the number 1,000, that'll give me the number that I would expect out of the 1,000 birds, which is about 317 birds. All right, now number 7. 7 friends together, respective partners, meet up for a meal, and then they want to arrange a photograph. They're all standing in a line. Now, arrange, keyword, we're talking about permutations. So anyway, we got 14 different objects. In this case, they're people. And so we can just represent them as numbers, 1 through 14, and put them in a line. And then we'll assume that 1 goes with 2 and 3 goes with 4, that these guys are partners. And see, now all we got to do is figure out how many different arrangements if they stay together. Well, we've got 7 partners, 7 couples, so they can be arranged in 7 factorial ways. Now the thing is, each one of these couples can stand in 2 different ways. So we've got to take that into account also. So that's going to be 2 factorial. And again, just to be clear, 13 and 14 could be 13 and 14, or they could be 14 and 13. That's 2 different ways that they could stand. Well, each couple has 2 different ways they could stand. So I'm doing 7 factorial times 2 factorial to the 7th power, because that's times 7, times 2, times 2, times 2, times 2, times 2. Anyway, what I end up with is going to be 645,120 ways. Now, number 2, how many different arrangements if the 7 friends are together and the partners are together? Well, so now let's think about the friends. They're going to say they're the odd numbers. And then we'll say the partners, they're going to be the even numbers. Now, I've got 2 groups now. All right, I've got odds and I've got evens. Now, if they're each group, the odds can be arranged, there's 7 of them, in 7 factorial ways. And the evens can be arranged in 7 factorial ways. And now I've got to keep in mind, though, these groups right now, one's on the right and one's on the left, they could be standing in 2 different ways, which is the same thing as 2 factorial. And so all I got to do is multiply all these ways together, 7 factorial times 7 factorial times 2. And I'll get 50,803,200, but that rounds to 3 significant figures of 50,800,000 ways that these people could stand. All right, now part B. We've got a group of 9 people, and there's boys, girls, and adults. And they want to know how many ways we can choose a 4-person team. Chosen combinations. That's key there. And they're going to give us requirements for this team. And the key to answering this question correctly is not to create requirements that aren't there. So all we've got to worry about is meeting their requirement. So anyway, number 1, the requirement is that both boys are on the team. Well, there's a total of 2 boys, and the way as I pick 2 of them is 2 choose 2. But the thing is, then I've got other people, because I need 4 people on the team. So the rest of the people, the non-boys, are 7 choose 2. So then I multiply these together, and I get 21 ways. Now, part 2, it says the adults are all on the team or they're not on the team. Now, there's 4 adults. So if I'm talking about a 4-person team, 4 adults choosing 4, there's only one way to do that, and I've got my team. That's if all adults are in. Now, the thing is, if none of the adults are in, well, then I'm going to consider all the non-adults. And see, I mean, that's a good way to think about it. If they're not boys, they're non-boys. These are non-adults. How many non-adults do I have? Well, there's 5 of them. And I can pick 4, any of those 4. And so the way I choose that is 5 choose 4, and there's 5 ways to get no adults, a total of 6 ways. Now, number 3, at least 2 girls are on the team. At least. So we got, first start off with, we've got 3 choose 2. That's if I choose 2 of the girls. And now that means I've got non-girls, because again, there's no requirement to be anything else. And then the non-girls, that's going to be 6 of them, and there can be 2, because I need a team of 4. So then I put that together, that's 45 ways. But the thing is, at least implies that maybe there's 3 out of the 3. So now there's only 1 left for non-girls, and that's 6 ways. Now, there's only 3 girls, so these are the only ways this can happen. So I add them together, and I get 51 ways. And that's all there is to that. Thanks for watching. I hope it helped.